This video was brought to you by Indently.io, learning Python made simple.
How's it going, everyone? In today's video, we're going to look at 5 of Python's weirdest features. Starting with feature number 1, triple comparisons. For this example, I'm going to create 3 variables of type integer. One's going to be equal to 10, the next one's going to be equal to 15, and the third one's going to be equal to 20. Now don't worry, we're going to change the variable name as well. Otherwise this would be quite silly. So A, B, and C. And obviously you could have taken the simplified approach by using multiple assignment, but that's not what I want to talk about. What I want to talk about are triple comparisons. For example, if you want to check whether C is more than or greater than B, and B is greater than A, for one of your checks, and here we can print that this check passed, you can do so using this syntax over here, and that will run just fine. But in Python, we have something that's a bit more Pythonic. And this is the triple comparison. Instead of comparing 2 different expressions and checking that they both return true, we can literally just remove this bit here and check whether C is greater than B, which is greater than A. And it will work the exact same way. But now let's take a look at the following code. Here I'm going to create a result of type boolean because we're going to use some comparisons. And what we're going to compare is an empty list to an empty list to an empty list. Now this is a quiz I use on a lot of beginners because it's kind of hard to understand what this will actually return. Logically, you'd think that this would evaluate to true, and then that this would evaluate to false. So that's one way of interpreting that. But if we were to run this and insert the result, you'll notice that we're going to get true as an output because that's not what's going on. By typing in empty list is equal to empty list is equal to empty list, we're actually typing in this. This is the comparison that's going on. And since both of them evaluate to true, it returns true. If you want this to return false, you're going to have to put this in parentheses because that's going to return true, and true is equal to an empty list is going to return false. So that's something to keep in mind when you're using Python's triple comparisons. Also, note that you can chain comparisons indefinitely. I might have referred to them as triple comparisons, but you can actually use this syntax indefinitely. For example, if 5 is greater than 4, which is greater than 3, which is greater than 2, which is greater than 1, is equal to 1, which is less than 2, which is not equal to 6, then we're going to print, not the property, but congrats. You wrote nonsense. And got paid for it. I'm sure your boss would love to see this. All jokes aside, I don't recommend writing this because it is hard to read. As always, follow your gut and what's most readable. That's what's important when you're writing code in Python. Otherwise, you might as well pick up C. Moving on to feature number 2, infinite references. And for this example, we're going to have a list of type integer, which is called A, and it will contain the values of 1 and 2. Then what we're going to do is append A to itself. Now the type checker is going to complain because A is not an integer as we've defined over here, but who cares? We're doing something stupid anyway. So let's print this and see what happens. And when you run the code, what you should notice is that we're going to get 1, 2, and a list containing an ellipses back. Now this is Python's way of telling us that we have an infinite reference inside our list. And what's interesting about this is that if we were to reference that reference, so that's at the index of 2, we would get back the same reference. And no matter how deep we go in, as long as we try to access this element over here, it's always going to give us the same element back. As you can see, we still got the same element back, even if we did this 1,000 times. I'm not going to do it 1,000 times, but if we did, we'd get the same thing back. The reference will always return a list that contains the reference as well. And this is probably something the average Python developer will never run into, but it's fun to know about nonetheless. Up next we have feature number 3, infinity. How do you represent infinity in Python? Well, the answer is through a float. And to do so, you just type in whatever you want your variable name to be, or you don't really have to create a variable, but if you want a variable to hold the value of infinity, you can do so by creating a variable. That was a long explanation that explained nothing. Sorry about that. But here we're going to type in of type float equals a float with the string of infinity. And if you want negative infinity, you can create a variable for that and just add a negative symbol in front of infinity. And by doing this, you've effectively created infinity and negative infinity, which means we can use those as values. Now we can check whether 0 is more than infinity or less than infinity. And as an output, you'll see that this will return false because 0 is not greater than infinity. But infinity is greater than 0. And the same thing goes for negative infinity. You'll see that 0 is greater than negative infinity, and that 0 is not less than negative infinity. Also, at any point in your program, if you decide to divide by infinity, what you're going to get as a result is 0. And if you're ever crazy enough to divide infinity by infinity, what you'll get back is not a number, which is another very interesting result. Moving on to feature number 4, implicit string concatenation. And this is one of my least favorite features in Python, and I'm sure a lot of other programming languages have it as well. But we're going to look at a couple of examples where I find it to be more annoying than useful. So in Python, if you want to create a string and concatenate that to another string, you can do so by using the plus symbol or the plus operator. And that will concatenate these 3 strings together. And then if we were to print this, what we would get as an output is A, B, and C. Another way to concatenate these is by omitting the plus symbols. And it's going to give us the exact same output. And that's because Python performs an operation called implicit string concatenation, which means if it finds one string next to another string, it's just going to combine them or concatenate them. And there's the argument to be made that it's quite useful for multi-line strings. For example, if we have a print statement and we're typing, this is a multi-line string, space, enter, or I actually wanted to type in that, makes it easy to write strings on 2 different lines. I've read a lot of comments that mentioned that this was a place where they would find it useful. Personally, I think this is a very poor excuse for a multi-line string. I really rather be forced to use the plus for clarity than rely on something as implicit string concatenation. But let me show you the reason why I really don't like it. And to show you, I'm going to create a list of elements, which will be of type string, and that's going to contain A, B, C, D, E, and F. We're going to use these 6 elements for our next operation. So here I'm going to print first the length of the elements, and then I'm going to try to access an element at the index of 5. A very simple operation, one would think. Now, if we were to run this, what we'll end up with is an error that our list index is out of range. And if we scroll up, you'll also notice that the length returned 4. And this silly bug was all thanks to implicit string concatenation. And I know this is human error, I forgot a few commas, one after B and one after D, but that's not something you can find. If you mess up on creating a list of strings, none of the error messages are going to point to this list of strings. So yeah, that's one of the major reasons why I don't like implicit string concatenation. And you'd probably guess that I don't like anything implicit by the way I annotate all my variables. And finally, for the final feature of today's video, we're going to be looking at something which is called name mangling. And I find this to be quite a weird feature. It's pretty useful, but still weird. And to demonstrate how it works, I'm going to create a product, which is going to take an initializer. And here we're going to put that F back because it's important and give it a name and an ID. Then inside we'll type in self.__name equals name. And the double underscore is important here because that's going to mangle this name. And I'll show you exactly what that means in just a moment. And we're going to do the same thing for ID, which will equal ID. Then I want to create a function called info, and that's going to take self and return a string. Note once again that I used a double underscore in front of info. This is important. And this will return to us self.__name with the ID set to self.__name underscore underscore ID. And finally, we're going to create a method called display info. And this will not contain a double underscore in front of it, which is also very important. And this will return none, since all we're going to do is print self dot underscore underscore info. And we need to insert self for this to work. Now below this, we can create our very first instance. So desk of type product is going to equal a product with the name of desk and an ID of 80085. Then we're going to type in desk.displayInfo as soon as I can find it. I don't know why autocomplete didn't want to help me out there. It's because... And I just realized I was doing this all inside the init block, which is very silly. Now if we run this, we should get back what we were supposed to get back earlier, which is a desk with the ID of 80085. So at the moment, everything works as expected. Now what we can't do is refer to any of this information. For example, we can't refer to name if we wanted to print that. This would not work. This attribute does not exist. If we tried to refer to the ID, that would not work either. Although to see that, we'd have to comment out this one. Then you'll see that this does not exist either. And finally, let's try to access the info. So underscore underscore info. And if we were to run that, it still wouldn't work. So in a way, we kind of created some private attributes in our class. And this is very nice if you want to create some functionality or some attributes which should only be seen within the class. Because once again, we cannot access any of this information by referring to the name directly. And that's because Python performs a little magic called name mangling. So to access any of this information, we need to refer to the class name. So desk underscore products underscore underscore name. This is what it gets mangled to during runtime. And we can do the same thing for ID and for info. Now, the next time we run this, we will get all of that information back. And since this is all being mangled at runtime, our code editor is not going to be able to spot this. It's not going to be able to understand where we got this information from. I mean, nowhere in our code did we create an attribute called product underscore underscore name or underscore underscore ID or underscore underscore info. We did not create any of these attributes anywhere in our code. So it's understandable that our code editor would not be able to spot this. And again, that's quite nice if you want certain functionality to remain within the class. Note that this was not how name mangling was intended to be used. It was pretty much created to help with name clashes when you're creating subclasses. And I have a full video that explains all of that in detail, which I will leave in the description box down below, in case you're curious to see what I mean by that. Otherwise, that's really all I wanted to cover in today's video. I'm very curious to hear what you consider to be Python's weirdest features. Please leave that in the comment section down below. I'm sure it will be a fun read. But otherwise, with all that being said, as always, thanks for watching and I'll see you in the next video.